Hi everyone. Today we're going to study basics of graph. To solve the Königsberg Bridge problem in 1937, a Swiss mathematician, Leonhard Euler, used the notion of graph theory. A graph theory is a branch of mathematics concerned with networks of points, sometimes called vertices or nodes, connected by lines or edges. Let us define some terms. Let us define graph. A graph, capital G, consists of capital V, a non-empty set of vertices or nodes, and capital E, a set of edges. Each edge has either one or two vertices associated with it called its endpoints. An edge is said to connect its endpoints. Example, we have this graph. In the graph G, the vertex set capital V with elements now A, B, C, and D. These are the A, B, C, and D. While the edge set capital E, we have E sub 1, E sub 2, E sub 3, and E sub 4. In the graph, E sub 1 is here, connecting A and C. E sub 2 is here, connecting A and B. E sub 3 is here, connecting B and D. E sub 4 is here, connecting B and C. We write edge E as the pair UV, which is the edge between the two vertices U and V. Next term is multiple edge. A multiple edge is more than one edge connecting same pair of vertices in a graph. If there are m different multiple edges associated with same unordered pair of vertices UV, then edge UV has multiplicity m. Let's define multigraph. A multigraph is a graph with multiple edges. We have a graph in here as an example with vertices A and B. We have three edges connecting A and B. So multiplicity here is 3. Next term is loop. A loop is an edge that connects a vertex to itself. In this graph, we see that there is a loop on vertex B. Another term is pseudograph. A pseudograph is a graph with loops and possible multiple edges. This is an example of a pseudograph. Next term is simple graph. A simple graph is a graph that does not have any loop or multiple edges. This is an example of a simple graph. There is no loop or multiple edges in this graph. Next term is endpoints. One or two vertices that are connected by an edge are called its endpoints. Next term, adjacent vertices. Two vertices that are connected by an edge are called adjacent, and a vertex that is an endpoint of a loop is said to be adjacent to itself. Next term, incidence of an edge. An edge is said to be incident on each of its endpoints. Next term, isolated vertex. A vertex on which no edges are incident is called isolated. Next term, parallel edges. Two distinct edges with the same set of endpoints are said to be parallel. Let's have example 1. Define the following graph formally by specifying its vertex set, its edge set, and a table giving the edge endpoint function. First, let us write the vertex set, and these are elements v sub 1, v sub 2, v sub 3, and v sub 4. For the edge set, we have e sub 1, e sub 2, and e sub 3. Now, the table with the edge endpoint function. For the edge, we write here e sub 1, e sub 2, and e sub 3. Now the endpoints for e sub 1, we have v sub 1, v sub 2. For e sub 2, we have v sub 1, v sub 3. For e sub 3, this is a loop, so we write v sub 3. We have now this as the final answers. Example 2. For the graph shown below, we will answer 5 questions. Question 1. Find all edges that are incident on v sub 1. Our v sub 1 is here. So for the solution, we write v sub 1 is incident with edges e sub 1, that is the loop, e sub 2, and e sub 7. Next question. Find all vertices that are adjacent to v sub 3. Let us locate the v sub 3, and it's here. So we write vertices adjacent to v sub 3 are v sub 1 and v sub 2. Next question. Find all loops. Observing the graph here, and we write loops are this e1 and e sub 3. Next question. Find all parallel edges. In the graph, we can observe that this e4 and e5 are parallel. So we write only edges e4 and e5 are parallel. Last question. Find all isolated vertices. There is one isolated vertex here, and that is v sub 4. So we write only isolated vertex is v sub 4.